Hello students, today we are here with one of the most important topics for your GET XC and Excel examination. And our today's topic is your microbial growth. Now this microbial growth topic, this is not only important in the food technology domain, but if you guys have chosen the Excel and in Excel if you have chosen the microbiology as your optional subject, okay? Then in that microbiology also you will have this microbial growth topic and it is covered in depth in that microbiology because that is the core subject and in your food microbiology, we will see the important aspect that are regarding our food. Okay, so our today's topic is microbial growth. Now, in this topic, firstly, what we have to see is what are the basic things like what is growth, why is it important, and there are many more things regarding the growth. Okay, you guys may have heard about the microbial growth curve and all the phases in the microbial growth curve. What is the function or what is the thing that is going to happen in each particular phase? So that is also important. So today we will see in depth about all the things that are regarding the microbial growth. Now let's start our today's topic. Now, today's topic is microbial growth. Firstly, you all people should be aware or you guys should know what is growth. If someone is going to ask you how you will define the growth, now what will be your answer? Mostly, some of you may tell like growth means increase in number. Okay, that is the thing in the case of microbes. Now, the second thing, growth means if you consider the example of a human being. Okay, then how will you define the growth? You will say like increase in size increases, height increases, weight increases. So all those things you can cover and all those things comes under the growth. Okay, so if you want to define the growth, then you will define like this. If you want to tell microbial growth, then what it will be? So here what you can see is what is growth. So growth may be defined as an increase in cellular constituent. It will lead to rise in cell number when microorganisms reproduce by processing like the budding and the binary fission. Means as I said, like if you someone is going to ask you what is growth, you will tell increase in cell number or increase in cellular constituent. Okay, when you are going to consider the example of a growth or like example of microbes or human being also, you will say like increase. Now increase in size, shape, that thing will be there. Now what happened basically, it will lead to increase in the cell number. Okay, obviously growth means increase, something is going to be increased and what it will be your cell number. So and how cell numbers are going to be increased? Cell number will increase by the process known as the reproduction. Now, when you go for the reproduction, in the case of microbes, so reproduction can be by the budding or it can be by the binary fission, or sometimes there can be asexual reproduction also. Okay, like there are many types. So here the processes like budding, binary fission, these we have taken as an example. So these processes will lead to increase in cell number, and that increase in cell number is nothing but that will be your growth. Now, besides this, there are many things which comes under the growth. Now, growth will also result when cells simply become longer or larger. Okay, that is increase in size. Cell become longer or larger. If the microorganism is coniocytic means that is it is the multinucleated, okay, multinucleate organism in which your nuclear division are not accompanied by the cell division. Means your nuclear division will be the separate thing and your cell division will be the separate thing in such things. Okay. Now the growth will result in an increase in cell size but not the cell number. Means if you have this cell, now it will after the growth it will become like this, but if this is the one cell, here also you will get one cell. It won't be two, four. Cell number won't increase. Only your cell size will increase in such type of cases. Okay. Now the thing is when your cell cycle is the complete sequence. What it is? It is the complete sequence of the events that are extending from the formation of the new cell through the next division. Means basically in cell cycle now your cell number is going to increase. Now that cell number will increase due to what? Due to division. Suppose if you have the one cell, now due to the cell division you will get two, from two you will get four. So this is the type of a chain that is going to occur in the cell cycle. It is nothing but it is the complete sequence. Okay, from A to B. Now from B you will get A and B. Now then A and B you will get another form, like from 1 you will get 2, 2 to 4, 4 to 8. Likewise it is increasing. It is nothing but it is the complete sequence that is extending from the new cell through the next division. Okay, this is these all things are going to happen by the division process. Now, most of the prokaryotes, I hope you people are aware with the prokaryotes and eukaryotes. Now, in the prokaryotes are reproduced by the binary feature. Now, some prokaryotes reproduce by the budding, fragmentation, and other means even if your most of the prokaryotes are going to be reproduced by the binary fission, but your some of the prokaryotes can be reproduced by the process known as the budding, fragmentation, and other means. Budding, for budding, basically, maybe some of you are aware, like budding is most probably it happens, or you can observe this process in the case of the yeast. Okay, even if you google these things, you can get to know how it looks like. You can see the picture. Suppose if this is your yeast, now there will be formation of small bird. This is nothing but this is the bird. Now this bird will grow bigger in size. It will have small bird over there. This is what how it will look. Okay, that is nothing but the budding. So in short, you can define growth like this. Okay, this is what the growth is. Now, when you go for the growth, okay, this is what you can define the growth. But the thing is, what are the requirements for the growth? Okay, it won't be like you are sitting at one place and you are increasing your height, you are increasing your size. It won't happen. Or even if you will consider the case of the bacteria, if you keep the bacteria at one place, it is not at all doing anything. And what you will uh, like you guys will have a desire like it will increase its cell number, it will increase its size. No, there is certain requirement for that bacteria. Okay, now what are these requirements, so that we will see. So when you go for the requirement of the growth, there are many requirements. In physiological requirements, you will have the temperature requirement, then you might have the pH, all the atmospheric conditions. See, if you are a bacteria or if your culture, it do not get this favorable atmospheric conditions, what will happen? It will not grow. Why? Because that conditions are desirable, that are required for the growth of your microbe. Okay, so hence what we will do, suppose if you are doing any type of the culture technique, okay, pour plate method or strict plate method that you are doing to see the number of colonies. Now, after culturing, what you do, you keep it in incubator for the certain period of time at a particular temperature. Now, that temperature is set. You cannot do if you raise the temperature to 90 degrees Celsius and you keep it there for the 12 hours or something, your culture will you cannot observe any type of growth colonies. Why? Because if your bacteria is not thermophilic, if it is the cycrophilic or if it is the mesophilic, and you are keeping it at a 90 degrees Celsius, it will die. It won't survive. Okay. So this is why your conditions or the your like this is why your favorable conditions are required for the growth. Now the first condition or the first parameter in the requirement of growth is the temperature. Now we know according to temperature you can classify the bacteria. You can classify the bacteria as the cycrophil, cytotroph, mesophilus, thermophilus, hyperthermophilus, okay, halophiles, osmophiles. There are many types according to the condition and according to the temperature. Now, when you go according to the temperature, what you can observe over here is if your bacteria is cold living, okay, if cold condition is desirable for them, then we call them as the psychrophiles. And for psychrophiles, the temperature is nothing but it is 0 degrees Celsius. Now, the true cycrophiles here you can consider like the seldom that can cause the disease or the spoilage. Now, when you go for the optimum, so optimum condition for the growth of optimum is the basic condition for the growth of most of the bacteria. So that is the 15 degrees Celsius, and it cannot grow after the 20 degrees Celsius. Now, in cyclotrophs, your temperature is 20 to 30 degrees Celsius. And these cyclotrophs are nothing, but these are responsible for the most of the low temperature food spoilage. Okay. When your bacteria has the low temperature requirement, so at that time you can go for the cyclotrophs. And whenever there is a spoilage at the low temperature, okay, so that spoilage causing microbe that are responsible are nothing but your cyclotroph bacteria. Now you will have the mesophilus. Mesophilus means nothing but you will have the temperature within the 25 to 30 or 25 to 40 degrees Celsius, and your optimum is the room temperature 37 degrees Celsius. Means if you are going to observe the spoilage at the room temperature, so you will have the mesophils that are going to cause the spoilage at the room temperature. Now you will have the thermophilus. Thermophilus are nothing but they are heat loving. They can survive under the high temperature. So up to what temperature? Up to 50 to 60 degrees Celsius, these thermophilus can survive. Okay, they are heat loving. And extreme thermophilus or hyperthermophile. So their optimum growth temperature is the 80 degrees Celsius. So what you can observe over here is hyperthermophile can survive under the very high temperature, that is the 80 degrees Celsius. Mesophiles, basically moderate temperature range. You can remember the room temperature, that is the 37 degrees Celsius, and it is best grown within the 25 to 40. And cold living, you can easily remember cyclotrophs. These are the 0 degrees Celsius. Some cyclotrophs can grow up to 20 to 30 degrees Celsius, which are responsible for the food spoilage that is caused at the low temperature. Now, this is about the temperature. Besides temperature, you will have the pH, you will have some other requirements, you will have the osmotic pressure, or some bacteria are there which are salt loving. We call them as the halophiles. Many more things are there. Okay. Now see, the second thing here is the pH. Now in the case of pH, what is going to occur? pH, basically the neutral pH range is 6.5 to 7.5. We all know your pH scale is nothing but it will be from 0 to 40. At 7, you will have the neutral. Okay. Now the moderate or the most neutral pH range is 6.5 to 7.5. Now, what will happen? Your most of the yeast that is there. So, yeast can grow in the wide pH range. Means yeast for growth of the yeast, it won't be like only the acidic condition is required or only the basic condition is required. It can grow from the acidic to the basic up to a wide range. That range is mentioned here. That is the 2.2 to 8.5. But basically, it prefer the range of the 5 to 6. Okay, it can grow under that 2.2 to 8.5, but preferable range is 5 to 6. Now you will have the acidophiles. Acidophiles are acid loving. They will love the acidic condition, and that is the pH is from 0.1 to 5.4. Now the lactobacillus in the acidophiles, you can consider the example of the lactobacillus lab bacteria. Lactobacillus basically they can produce the lactic acid tolerant mild acidity, and then when you go for the neutrophiles, so neutrophiles from the word neutral, you can guess it will love the neutral condition, that is around the pH of the 7. So these neutrophiles, these are best grow at the pH of the 5.4 to 8.5, and these neutrophiles will include some of the human pathogen in the case of neutrophile. Now you have the alkali philes. From the word alkali, it is above 7. Now the alkaline pH is 7 to 12 or higher. You will have the examples of the soil bacterium, agrobacterium, which can grow at the pH which is around the 12. So in pH also, you will have the types of bacteria like which are acidophiles, neutrophils, and alkaliphiles. Okay, so according to their range, they can grow. Now, third condition over here is the osmotic pressure. Now, in the case of osmotic pressure, your cells are basically 80 to 90% of water. Now, there are two types of solution. One will be your hypertonic, another will be your hypotonic. Now, in the case of hypertonic solution, high osmotic pressure is there. In the case of hypertonic means high osmotic pressure. Now, this high osmotic pressure, it will remove the water from the cell and it will create the shrinkage of the cell. If, suppose, okay, over here, if this is your cell, okay, it is rich in water. Now, what will happen if you are going to remove the osmotic pressure? It will get shrink like this. Its size will decrease. It will be like compact. If you have this type of cell and if you remove the water from it, it will get shrink. It will reduce its size and it will become like this. Okay. So this is what happened. Now this process is nothing but the plasmolysis. What it is known as? It is known as the plasmolysis. Now, when you have the hypotonic solution, okay, hypotonic. Hypotonic means low osmotic pressure. Now, low osmotic pressure, what it will cause? It will lead to enter the water to enter the cell. In the case of hypotonic, what will happen? You will have the low osmotic pressure. As you will have the low osmotic pressure, water can easily enter into the cell. And in most of the cases, cell wall present entry of the water. Microbe may burst or lyse if cell is big. Means if this is your cell, in the case of hypotonic, we are talking about hypotonic. Water will enter and your cell size will increase. And what happens if your cell wall is weak? Now, your cell may get burst. Okay, it will break. It will break. In the case of hypotonic, if your cell wall is weak. Now the third thing, you have the halophiles. Halophiles means salt concentration. Moderate to large salt concentration is required. Basically 3.5% of salt is required for most of the ocean bacteria. Okay, in the case of halophiles, it is moderate to large salt concentration. Concentration of 3.5% salt that is required. Now when you have the extreme or obligate halophile, halophiles means salt concentration, and these are extreme. Extreme means they will require high, so they require very high salt concentration, that is up to 20 to 30% bacteria in the Dead Sea, brine vat. Okay. Now, when you have the facultative halophile, facultative means they do not require high salt for the growth. They just adapt the condition according to their requirement or according to the surrounding changes. So this is what important is the temperature, pH, and osmotic pressure, how these conditions are required for the proper growth of your bacteria or the microbe. Now, when these are all your physiological requirement, when you go for the chemical requirement, obviously some type of chemical requirement may be there. So, on the basis of the carbon source, if you have the carbon source for the chemical requirement, now from that you will have the chemo heterotrophs and you will have the chemo autotrophs. Okay, and then you have the photoautotrophs. Now, what is chemoheterotrophs, chemoautotrophs, photoautotrophs? Their examples are there according to which source they are classified, whether it is light source in carbon, whether it is organic, inorganic. So, to study all these things in depth and to know basic of these things, you can join our target batch. That is target batch Gate XC Excel 2024. Okay, in that, in our live classes, you can easily get the idea about what exactly it is, and in depth we have studied this over there. Now when you go for the carbon chemical requirement, in chemical requirement you have the carbon. So for carbon you will have the chemo autotrophs, heterotrophs, and photoautotrophs. So photo is nothing but the light source. On the basis of that you will have the photoautotroph. Now when you have the oxygen requirement, so on the basis of oxygen you will have the aerobic, anaerobic. You will have the obligate aerob, that is compulsory. They require the aerobic condition. These obligate anaerob will, it is mandatory to have the lack of oxygen, that is the, in the absence of oxygen this will grow. You will have the facultative aerobes. In the case of facultative aerobes, just like you have the facultative halophiles over here, they have the same situation. Okay. In the case of oxygen, you have the obligate aerobe. So the example is Pseudomonas, which is considered. Then you have the facultative aerobes, obligate anaerobes, aerotolerant anaerobe, and microaerobe. Micro means in less amount, they will require the oxygen. Now, the very, very important point from the microbial growth curve is nothing but how this growth curve is going to happen. What are the phases in the growth curve? This is the most important topic from your microbial growth. Okay. Maybe you guys are already aware with the microbial growth curve. Basically, this growth curve, it has the 4 phases. Okay, now what you have to remember is what is there on the x-axis, what is there on the y-axis. On the y-axis, you will have the time. On the x-axis, you will have the log number of the viable cells, means how your microbes are increasing. So that cell number you will have on the x-axis. On the y-axis, you will have the time. You can see over here. Here it is time, here it is log number of viable cells. Now see, it is 4 phase. As I tell, it is 4 phase reaction. It is 4 phase growth curve. So first is lag phase, second is exponential, that is your log phase. Third one is stationary, fourth one is death phase. Now what is going to happen in each and every phase? Like lag phase is the most initial phase. Now exponential, from the growth curve, by looking at the curve or the graph, what you can guess or what you can observe. Okay, so if I ask you what you guys can observe by looking at this graph, so what you guys should tell me is basically in the lag phase, just it is starting of the growth curve, it is starting of the microbial growth curve, and what exactly is happening over here is cells are adapting. There is not increase, but with the time, cell number is constant. Can you observe? Like, is this okay? Wait a second. Is it like this? No, it is like this. Okay, so here they are adapting to the condition. There is no increase in number. Now, from this point, what you can observe? Slowly and steadily, there is the log number of increase in your microbes. Means here, your microbes are increasing. Okay, microbe number increasing. Now till here your microbial number is increasing. Now from here in the stationary phase, again what is happening? Your cell number is constant. है You can see over here in stationary is it is like this. Is stationary phase like this? No, it is the steady one. So here your cell number is constant. Now here what you can see, there is the decline. Decline means your cell number is reduced. In the death phase, your cell number is reduced. Okay, now this is what we have to study in depth. What is lag phase, log phase, stationary, and death phase. Now see, in the case of your lag phase, what you can observe when microorganisms are introduced into the fresh culture medium, usually no immediate increase in cell number occurs. So this is the lag phase. As I told you, there is no immediate increase. If this is your growth curve, this is your lag phase. This is your cell number on x-axis. Here you have the time. Is there any increase? No. It is just a straight line. There is no increase. This line is not like this. Now, if it will be like this, then you will have the increase. Now, in the lag phase, there is no increase in cell number. Although cell division is not taking place, means due to cell division, cell number will increase. As cell number is not increasing, obviously your cell division is not at all taking place over here. But what is there is they are just adapting to the conditions so that they can synthesize the new component. Okay, a lag phase, it is prior to the log phase, and basically it has the variety of reasons. Okay, it is just adapting to the condition due to what? Due to some cells, they can be old. Some cells have the lack of ATP. ATP is nothing but adenosine triphosphate. So some cells are old, some have the lack of ATP. There are some of the essential cofactors. Some will require the ribosomes. So due to all lack of or depletion of such type of nutrients, so cells are adapting. They are just taking the nutrients. They are preparing for the growth. Okay, then in the log phase, they will have the cell division and then their cell number is going to be increased. Now the lag phase varies considerably. Okay, it varies in length with the condition of the microorganism. Means what is the nature of your microorganism? What are the environmental conditions? So depending on that, your time for lag phase will vary. If you have the effective favorable conditions, okay, if you have the favorable atmospheric conditions or the surrounding condition for growth of the microbe, what will happen? Your time required for lag phase will be less. But if you have the worst condition, so that cell cannot adapt, so that thing in that case, what will happen? Your time required for lag phase will be more. Okay, because bacteria will require time to get adapted to the environmental condition. Even if you have the old culture, your time required will be long. If you have the fresh culture, time required will be less. So in lag phase, basically what you have to remember is cells are just adapting to the conditions, environmental conditions. Depending on that, their number may vary. And the most important thing is here, cell number is not at all increasing. Okay, that is what you have to remember. When we go for the log phase, from the word log, there is exponential or there is logarithmic growth in the cell number. Okay. Now dividing the exponential or the log phase, microorganisms are growing, dividing at the maximum possible rate. They are just increasing their number at the maximum possible rate because they have already adapted to the conditions. Now their only work is to just increase the number. Okay. So hence they are increasing their number logarithmically. Now the nature of the medium and the conditions under which they are growing. So their rate of growth is constant during the exponential phase. So this is what you have to remember. They are growing, but their growth rate is constant. Okay, it is not at all varying. Their growth rate is going to be constant. So this is because each individual divide at a slightly different moment, the growth curve rises smoothly rather than in discrete. Means see, what does it mean basically? This is what your growth curve is. This is your lag phase. Now how your log phase look like? It is like this. Then you have decline and death. Is it like this? Is it like this? No, nah, it is not like this. Why it is not at all like look like this? Because you will have the smooth increase. Why smooth increase? Because the thing is growth rate is constant. Growth rate is constant. If you have the different growth rate, means if your growth rate is not constant, then your curve will look like this. Okay, if it is not going to be constant, so your curve will look like this in the discrete nature, not a continuous nature. Okay, so exponential growth is your balanced growth. That is, all the cellular constituents are manufactured at the constant rate relative to each other. And if nutrient level or other environmental conditions change, unbalanced growth may result. Okay, so nutrient level and the environmental conditions will have the impact on the growth of the log phase. Now you will have the stationary phase. So in stationary phase, what you have to remember is cell increase is equal to cell death. Okay, increase in cell number, at the same time cell are going to be decreasing. So here in stationary phase, your cell number will be constant. That's why in graph you can see your stationary phase look like this. This is your stationary phase. It is straight line. That is, it is constant. It is not like this. Not fluctuating, increasing, decreasing. No. Cell number is constant. So this is the closed system, population growth. So eventually what will happen, as this is the closed system, your population growth will cease. Okay. And the growth curve become horizontal, look like this. Now, the stationary phase usually is attained by the bacteria at a population level of around, this is 10 to the power 9, of around 10 to the power 9 cells per ml. Other microbes normally do not reach such a high population. They won't reach, okay? They may have the maximum concentration of the 10 to the power 6 cell per ml. Now, in stationary phase, what is going to happen is your the total number of the viable microorganism, it remain constant. This is what you have to remember. Total number of viable microorganism remain constant. As I said, your total number, cell number is going to be remain constant. Increase in cell, at the same time as two cells are increasing, two cells are dying, three are generating, three new cells are forming, three cells are going to be dying. So this is how your cell number is going to be constant. Now your microbial population will enter the stationary phase for the several reasons. One obvious factor over here is the nutrient limitation. Now, if the essential nutrient is severely depleted, population growth will be slow. If your nutrients are decreasing, then your growth will be slow, because for the growth of microbe, nutrients are required. Aerobic organisms often are limited by the oxygen availability. Means if oxygen is not properly available, obviously your aerobic microorganism will not grow, because what? Why? Because they require oxygen for their growth. So this is the stationary phase. Now in the fourth phase, that is, this is your last stage in the growth curve. That is nothing but the senescence and death, means death phase. Okay, which we have seen in this graph. This last phase, this is the death phase. Now, in this death phase, from the word death, what you can guess is your cells are dying, cell number is going to be decreased. As the cells are dying, cell number will decrease. The decline in the viable cell following the stationary cell was described simply as a death phase. That is, decline in cell number, for which is this stage will occur after the stationary cell. Now, it was assumed that the environmental changes like the nutrient decrease, that is nutrient deprivation, and the buildup of some toxic waste cause the irreparable harm resulting in the loss of viability. Means why cells are dying? No, you should have the question in your mind why the cell number is decreasing. So cell number is decreasing because there is the decrease in the nutrient, because cells in the lag phase, bacteria has consumed the nutrients and all that. That's why they have increased their number. So as they are increasing, they are consuming the nutrient, and thus the nutrient shortage can occur. Till the end, nutrient shortage will be there. So due to that, your death phase will occur. Now the phase start due to exhaustion of the nutrient, accumulation of some of the toxic product, and due to some of the autolytic enzyme. There is the decline in the viable count and not in the total count. Now, with the autolytic bacteria, even the total count show the phase of the decline. Means here your bacterial in senescence or death, what you have to remember, your bacterial cell number is going to be reduced. So this is what happening in the senescence and death. Okay. I hope you got it. What is your lag phase, log phase, stationary phase, and decline phase? Now, what are the types of questions that will be there in exam on such topic? Okay. See, in this topic, now there is in depth about the, because you will have some of the numericals from the microbial group. So to learn those numericals, learn those tips and tricks, how to solve, what are the simplest formula to remember, and how to derive the formula, even if you do not, even if you are not able to remember or memorize it. So that we will, for that you can join our live batch. Okay, in that batch, in live session, we will teach you how to solve those numericals and what. But if by considering the theory, if you want to check what type of question will be there, so see the question number 1. For the microorganisms, they are start dividing rapidly at the highest possible rate in which phase? As in the theory slides, in previous slide, we have seen in lag phase. In lag phase, they will start dividing rapidly. In log phase, are they divide in log phase? They are increasing their cell number. Okay, but in the case of lag phase, they just start. That is the initial phase. Now see the second question. The growth of the bacterial population follows a geometric progression. Is it true or false? So it is true. Why it is true? Because the bacteria show growth by following the binary fissions. Okay, due to this process like binary fission or budding, 2 to 4, 4 to 8, their number is going to be increased. So thus if we start with the single bacteria, the increase in population is by geometric progression. If from 1 you will get 2, 2 you will get 4, this is nothing but this is the progression. Hence this statement is your true. Now, in third type of question, see, if the growth equation n is equal to 3.3 log 10 of log to the base 10, log n to the base 10 and log n naught to the base 10, this is subtracted. So here this n is going to be stand for. Now, how this equation is derived? So there is a proper derivation behind this and how to remember it. There is also one trick. But here what we have to remember is what is this n, what is this n naught or n. Okay, small n, capital N, n naught, so that you have to remember. So that we have covered in depth. This will be basic. Now this n is nothing but your number of generation. Okay, this n stand for number of generation. How many generations have taken place to find out the population. Initial population n naught and final population and final growth, initial growth. That is there. Okay. So to study the growth equation, to learn how to solve the numericals based on the microbial growth, you can join our live sessions. In that, you can have the good command or good hold on this topic. Okay. So thank you for attending the session. If you for more such informative session, you can just like the video and please subscribe the channel. Okay. Thank you.